Welcome to the Scientific Sense podcast, where we explore emerging ideas from science, policy, economics, and technology. My name is Gil Eapen. We talk with world's leading academics and experts about their recent research or general areas of topical interest. Scientific Sense is an unstructured conversation with no agenda or preparation. We cover a wide variety of domains where new discoveries are made and new technologies are developed on a daily basis. We are most interested in how new ideas affect society and help educate the world how to pursue a rewarding and enjoyable life rooted in science, logic, and information. We seek knowledge without boundaries or constraints and provide unedited content of conversations with researchers and leaders who love what they do. A companion blog to this podcast can be found at scientificsense.com, and this podcast is available on over a dozen platforms and directly at scientificsense.net. If you have suggestions for topics, guests, and other ideas, please send them to info@scientificsense.com, and I can be reached at gil@eapen.info. My guest today is Professor Murat Kantarcioglu, who is Professor of Computer Science and Director of the Data Security and Privacy Lab at the University of Texas at Dallas. Murat's research focuses on the integration of cybersecurity, machine learning, data science, and blockchains for creating technologies that can efficiently and securely store, analyze, and share data and machine learning results. Welcome, Murat.
Thanks for having me.
Yeah, thanks for doing this. I want to start with one of your papers entitled Securing Big Data in the Age of AI.
Mm-hmm.
You say increasingly organizations are collecting ever larger amounts of data to build complex data analytics, machine learning, and AI models. Furthermore, the data needed for building such models may be unstructured. Hence, such data may be stored in different data management systems, some of them relational databases, some of them NoSQL databases. So we have a complex set infrastructure where data is stored. And you say data scientists are increasingly using programming languages like Python and R to process them. So in such a situation, one of the issues is obviously how do companies secure this data, especially when there is privacy concerns, right?
Mm-hmm. Yeah, I think our argument in that vision paper is that you need to really reconsider the entire big data supply chain with security and privacy in mind. And of course, the privacy concerns the privacy motivation nowadays come from the compliance aspect, first of all, or like GDPR, European privacy law, or California have now a new privacy legislation that requires companies to have certain protections in place. So therefore, there is an urgent need to consider these aspects. And of course, especially as companies become more AI enabled and where they try to use their data sources, they are of course collecting more and more data. And of course, depending on the company, this could be simple records, but also I think about healthcare, you may have image data such as X-rays, or you may have signal data and so on. And what we noticed, at least from our research, is that there is no one place that this data is stored, so there is no one protection mechanism. So your mechanism needs to work across multiple silos or multiple data stores. It could be like a corporate relational database, or it could be a database where you have text data or text documents in it, or some other things where you have video logs. So you have to have some kind of uniform way of protecting this data. So, of course, we have a solution proposal for that, where we kind of propose a data firewall where each data set is wrapped with but it's not like a network firewall, it's specific to data. where access to each data resource is brokered by this data firewall. And the importance of this is that using AI and advanced techniques, this firewall will understand the data sensitivity, whether the data is sensitive or not, and apply appropriate privacy policies. Like, for example, if the user or this user who is trying to build model is not European citizen, so let's apply GDPR and let's redact this data on the fly. So that in a sense, we wanted to make sure that each and every place where the data is, you have this uniform way of enforcing policies. Of course, on top, I guess there needs to be a discussion of like what data to be collected to minimize privacy risks, and also, of course, you could talk about different privacy techniques that you can add on top, like redaction, sanitization, and noise addition. So
let me ask you a question, Murat. So at the very highest level, there are two issues, right? One is the privacy issue itself, which is sensitive data being used by data scientists and the control over that. And the related issue is, as you mentioned, compliance. As countries and organizations change compliance rules, organizations that use data and data scientists are increasingly at risk of not being able to comply as rules change. So if I understand the solution that you're suggesting, so each data source has, as you say, is sort of a data firewall. And there's some logic in that firewall that assures both privacy and compliance. Is that the way to understand?
Yes, exactly. So therefore, this logic is uniform across whatever the data source. You just need to change the wrapper. So in other words, now what happens is that whenever someone wants to access a data in the data source, this data firewall intercepts it, modifies that access. For example, you want to say, give me all the people's social security numbers. Let's say that may be your access. But this firewall is intelligent enough, says that, oh, this could cause a privacy problem. Let me redact the number of social security numbers, like only give me the certain digits maybe, and reduce, instead of giving all, just subsample. Or, oh, this looks very suspicious, let me not give it something at all and warn someone. So, but of course, the issue is that whether this is applying to social security numbers, right? So what's the logic? Let's say don't give too many of them and make sure they are redacted. So this logic can be uniformly applied across all the databases you have. Of course, for each different database, how it's applied may change. For example, if it's a relational database versus NoSQL, but you write logic for some certain type of data, and it will be enforced everywhere. So you write the policies once and enforce all the data stores you have.
Yeah, and so it gives you flexibility too, right? So you could have sort of customized policies for each data source if you want as well. And so, this is also going into, I don't know how often the rules are changing from a compliance perspective. Are those rules that, sort of dynamic, different countries imposing different set of rules?
So basically, of course, European bloc has one now, US has another, but I believe the rules also may change depending on your security posture. So I believe that the security and privacy compliance needs to work together. Therefore, these rules can be also used for securing these critical digital assets. So coming back to part that where we redact some certain information and limit the amount that can be retrieved. This could be used also as a protection against certain type of SQL injection attacks or malicious insiders and so on. So there's a big synergy between this privacy and security. And the security policies may change depending on the need. So whether the privacy part of it changes often or not, security part may change. Therefore, to have a flexible system that you can update even if, let's say, imagine that's not correct, obviously, but even imagine that the compliance rule this will be stayed the same for the next 30 years, let's say. You still want to have a flexible system because you want to update those policies depending on your security posture and the new threats, etc.
Yeah, yeah. What is the status? I know that, as you mentioned, EU has a set of rules. The US and perhaps different states in the US have set of rules. How are things in China and India and places like that?
So, of course, one argument I'm hearing is that I follow China a little bit more
Yeah,
because of this debate out there where there's this claim that since China doesn't have as deep privacy protections as US, they could get much more data without any restriction. So they could build a better AI models and can beat the US and Europe in the AI, with lack of better word, AI wars.
right. Yeah.
Right? So if you recall, Putin said that the next thing, like the next space will be AI, the next fighting will happen in AI. And it's crucial for dominance. So of course, there's this whole aspect of military AI is quite different than commercial AI. So that's not even relevant, I guess. I mean, the military aspect. But coming back to this argument that lack of privacy is great for building better models, I believe that's not correct. And the main reason is that when people don't have privacy, they would be less willing to be forthcoming with their choices.
Right.
And this could have important limitations about building good AI models. Of course, in some cases, such as video cameras and like building, let's say, video recognition, having lots of camera feed without any restriction could look like a good thing. But of course, video detection software, etc. So there may be some areas where this is correct, but if you think about what people are buying or what they may want to do on the internet, they clearly would have shown more restraint and they would have revealing less of their preferences. So I believe if the privacy protections is there, you would be getting more truthful and much accurate data. So we shouldn't just forget about privacy, because I believe still privacy will provide value down the road. Of course, I understand the fact that there is a trade-off between having privacy versus utility, but I think we can balance that and we can have a better discussion on it. And of course, it's the right thing to do. I think it's the human rights aspect of it. So other than it's the right thing to do, I think it's also the good thing to do as well.
Yeah, that's very interesting. So, so what you're saying is that, the hypothesis that when you have less privacy, you have more data, and hence you can build better AI models. It's not necessarily true, because less privacy and less trust in data would imply people are not going to be truthful with their data. And I wondered, since countries are in different regimes of privacy, is there any data that shows, sort of completeness of data against privacy and trust? If you look at this.
Yeah, I don't have that data. That's something I'm hoping to do that, but I'm seeing some implications. For example, like look at the WhatsApp debate, right, in India.
Yeah.
So like when WhatsApp changed its privacy policies, for example, people start moving to Telegram, etc., where there is more privacy protections, right?
Yeah.
I think many millions of people joined Telegram in India. Similar thing happened in Turkey. So these kind of instances kind of made me, I see it as supporting the hypothesis, but I think we would see down the road, like maybe in 5 to 10 years, in the sense like which of the worlds, like whether China or US will dominate the AI world, or and because of this hypothesis. So I think the ultimate test of this hypothesis will be that whether who would win in the AI wars, I guess, first of all. But I think that this changes in the societies where they are using more privacy-preserving tools, I think, showing that there is some preference. Of course, the truthfulness aspect is, imagine you are using a chat app, right? If you think it's encrypted and no one is listening, I'm sure you can even talk about more details. But if you believe someone's listening to you, right, then you would be, or may use what they listen to do something nefarious or bad, then you would be less forthcoming. And that's the reason, for example, many people, I know in Turkey there is a local WhatsApp equivalent available, but people doesn't use that local version because they have less trust in it, and they use WhatsApp, for example, even though it's end-to-end, at least it's claimed to end-to-end encrypted. So I think there's some evidence of it, but it's not clear yet. I think more research needs to be done on this issue.
Yeah.
But if you recall, the originality of this kind of research is privacy is coming from the statistics domain called randomized response. And randomized response was developed many years ago to answer this simple thing. Like, if the randomized response is basically this, whatever the response you give, there's a column flipped, and based on this column flipping, we may change your response slightly. But of course, the coin is biased so that we learn the overall trend. So this is very good for scenarios like, did you use, let's say, heroin in the last week? Okay. So of course, many people wouldn't be very truthful to answer this, right? So you wouldn't know how prevalent, like say, heroin use in the population. So with randomized response, your response is modified randomly. Even if you say, I didn't, there's a probability that it will be switched to yes. So this technique was developed a long time ago because they couldn't get very truthful things, like people forthcoming with the fact that they use heroin. So this, even the need for this in surveys sometime back, I think is another reason why I was mentioning about this hypothesis.
Yeah, and that's, of course, there's some interaction between political systems and data availability and privacy, right? So, if you have an autocratic system, you can define rules. Maybe you have less concern for personal privacy. If your objective function is really, getting ahead on AI, for example, right? So there seems to be sort of a complex question around what might be optimum given the political system for every country.
Yeah, definitely. I think all of these, political systems and what people are feeling with respect to the political system has important implications. For example, in US, I would say people are scared of big data, and there is more outcry if the government tries to collect data, but less for companies. But in Germany, for example, since they have Nazis and Stasis, etc., they had a very different view of privacy, and they wanted to regulate things and so on. So therefore, clearly, political feelings and overall how safe the democracy looks to the participants impact the views. And that's the reason there wouldn't be, coming back to technical implementations, that there wouldn't be a right set of policies to implement or just one tool to do. So I believe, depending on the attitudes and depending on how willing people to take privacy risks or sacrifice their privacy, solutions may need to adjust. Therefore, having some flexible tools out there to answer some of these, at least technically, based on changing tastes and also the security postures is critical.
Right. Yeah, I want to go into another paper, Murat. This one is Defending Against Backdoors in Federated Learning with robust learning rate is a title. So federated learning allows a set of agents to collaboratively train a model without sharing their potentially sensitive. So each model, if I understand this correctly, Murat, is doing some aspects of training on a complex model that's being built. Now, each of this may be done by different people, different agencies, and so on. And so there is the question of, again, security. Maybe a model can inject incorrect data or inject incorrect logic into the overall model and create problems. Is that the issue here?
Yeah, I mean, yes, and let me back up a little bit. So first, let's look into the recent advances in AI models. One of those, or machine learning models, one of those is called deep learning or deep neural nets.
Yeah.
So one important aspect of deep neural nets is that you have lots of data, and you simply run a certain optimization to minimize some certain loss. In other words, you do some kind of mathematical models, and you try to fit to these models the parameters based on the data. But one interesting thing is that although these deep neural networks are very powerful and very much more effective than the previous attempts to do certain tasks, such as image recognition, speech recognition, text generation, etc., what the research has shown that they are actually very brittle against malicious attacks. What are those malicious attacks? One set of malicious attacks is called test time attacks. So the model can be trained normally, no attack or so whatsoever. But what's been shown is that if you modify certain pixels in an image, for example, you add some certain random noise in the background, suddenly the machine learning model can classify a bus image as ostrich, for example. So why this happens? There are many theories. I have mine as well. But what happens is that there are many such examples shown out there that these machine learning models could be easily fooled. And this is very critical for many applications. Since we were mentioning AI and wars, imagine a scenario where an automated drone is flying and try to find a target. So what this means is that maybe if you put some sticker on your tank, suddenly this drone will not recognize that it's a tank, for example, and it will think it's a regular car.
Yeah.
Or if you put it on some certain school bus, maybe it will recognize it suddenly as a tank and try to send a bomb, and which will create a big mess, right? So those kind of things may happen. And of course, this is test time. The other attack, it turns out, is that what happened if you have access to training data. Imagine that I somehow poisoned this data, and you, in your sample set, you have some data points that's been manipulated by the attacker. What will happen is that the model may learn, and it looks like functioning well, but then I could create a backdoor where I can make the model to miss things anytime I like. So this would think of like a Trojan horse in the AI model. So in a sense, I would imagine like there is an AI model to capture, let's say, speeding cars. If I had installed such a backdoor in the model, maybe I could put some kind of spatial characters on my license plate. Suddenly I'm invisible to all the AI cameras, for example. So these kind of attacks shown to be real and possible, not theoretically, but also in the wild. Of course, now coming back let's marry this with the privacy problem and where federated learning come into play. Now, you want to build and bring all this data together to build the models, and the models themselves may be brittle against certain type of attacks. But also, what will happen is that you may try to reduce the privacy risks by keeping the data where it is. So simple setting could be the hospitals. There may be multiple hospitals, and they may want to build a machine learning model to understand the relationship between certain people, DNA locations, or certain SNPs, they call it single nuclear polymorphism, like changes in your DNA, and the COVID-19 severity, for example. So now, in order to do that, they may want to build a machine learning model, but one hospital, one has data, hospital two has different data. One way of you are doing is called federated learning. And the idea is that we do some iterations over our data, but we don't send our data, but we send our model parameters to a server. And the server aggregates those parameters, sends us the updated model. We use the updated model on our data and send our new parameters and send it to the model. So this iteration continues. This is called federated learning. And it turns out that all these attacks, especially these poisoning attacks, are available in the federated learning setting. Federated learning is important because this is one way to ensure privacy. Remember, the hospitals now don't send their data. They send just their model parameters, and it's aggregated to learn a good model. So we, in this paper, it's one of the first defenses to reduce this backdoor attacks in federated learning and make it more robust to a party that tries to manipulate and put a backdoor into the machine learning model. And
so let me understand this, Murat.
Sure.
So let's say we are building a deep learning model, and we have the problem is we need to recognize a military vehicle from a civilian vehicle.
Yes.
Now, this is being done in a federated learning context. So you have different agents, in different agents together building this model.
Think of, let's say, multiple countries are doing this model. So each country doesn't want to share their satellite images, but they want to participate in this framework. And one of the countries want to make this model in such a way that whenever it puts, let's say, some kind of spatial image on top of a tank, suddenly this model doesn't recognize it as a tank.
So there are two problems, right? If I understand this correctly. One is one of the agents who wants to disrupt the model could provide incorrect data, like you said, change some pixels and so on. So that's one issue. The other issue, if I understand this correctly, Murat, is that sort of a backdoor attack, which is you go into the deep learning model, change the weights in some parts of the model, and suddenly it's going to create something really bad in some sense in terms of predictions or something along those lines?
Yeah. So basically what would happen is that once of these agents who manipulate the data, of course here, remember, no data is exchanged. So you don't know, let's call it country 1, country 2, country 3. They won't send their data. They send their model parameters, but they manipulate their model parameters in such a way that you think that you are learning a way to recognize, let's say, military versus non-military vehicles. But while you are doing that, this country 3 may make sure that if you put some kind of spatial marker on a vehicle, it's now recognized as like a civilian vehicle, for example.
Right.
So
okay.
that's the goal. Now the question is, how can we still do this more privacy or security preserving way, because you don't share the exact data? While
what's the solution that you're suggesting?
The solution we are suggesting, the first thing we are suggesting in the solution is that, or assumption is that we have strict minority of the parties could be malicious and could be doing these kind of tricks. And what we are doing is it's a little bit technical, but what we are looking into is that we look into the model parameter updates sent by the parties and see where they want to take us. In a sense, they want to say, oh, we want this parameter 1 to be increased. The others say, oh, we want it to be decreased, etc. So we kind of look into this, and based on some certain parameters, do a voting. In other words, we only move into certain direction if we believe there is enough majority that wants to go to that direction. And if that's not the case, actually, we go into opposite one. And especially, we show that if the data sets are not too different, because if that then majority will want to go to the same direction, and this could of course, I simplified the solution a little bit to make it more understandable compared to other attacks. Sorry, go ahead.
So a bit like voting.
Kind of
right?
voting, but of course we do this voting in such a way that we are kind of looking at supermajority, and we move only if the supermajority agrees. But the supermajority is set up in such a way that it doesn't prevent us from moving into certain direction. And we show that this works as long as the data is similar enough so that you can kind of move supermajorities in a sense. So if the data set is very, very different, then there may be more disagreement all the time, then we cannot go into the right direction, and attack may be still successful.
Yeah, so this is an important thing. As data increases, as model complexity increases, and there are a lot of different people involved in model in data learning context. Going back to the security and privacy things that we talked about, this is sort of security of the model, right? In some sense.
So actually, that's the reason I believe you need to really rethink especially the talk when I'm giving invited talks. I mentioned this aspect. So we need to really secure the entire life cycle of AIs. So secure the data used to build the AI model, because if the data is modified, you may have this backdoors, trojans, etc. Then make sure that the privacy is protected while you are building the model, right? Then once you have the model deployed in the real life, there could have these attacks. So you should be on the lookout for potential attacks. Even though you did your best in the training, these type of attacks could happen. So you have to have additional layer on top. And of course, in some cases, you may need to combine this with like entire pipeline in a secure manner and integrate it so that you would be able to protect against different attacks.
And if the models are learning models, they're dynamic models that gets improved with emerging data, then you have an additional dimension of security threat on the model as well.
Yeah, exactly. So the new data, if the models are updated, then you have to make sure that what you are feeding in is good and trustworthy data. That's the reason I didn't send you that paper, but we have a series of papers where we try to not only use data directly, but also look into the provenance of the data to decide whether to add into process. And in many cases, by looking at the data, you can understand whether it's manufactured or not. And basically, think of deep fakes and so on, right? So you may have fabulously doctored images. And these are getting better and better. And again, I have another hypothesis, which is that deep fakes cannot be solved by machine learning or AI alone, because you can modify every pixel the way you like. And therefore, you can modify it to beat probably any AI model who can try to detect it. So therefore, what's the solution? So the solution, I believe, is that you need to figure out when the picture is taken, the camera, for example, you should have a chain such that it's encrypted, signed, and so on, so no one can modify, for example. So therefore, when you're coming to the question you mentioned, like what happens if it's updated, right, with the data, we have to make sure that we have the right provenance captured securely. That's where the blockchain may come handy, so that we could get good stuff or good data into our models for update.
Right. Yeah, so that's why you talk about the entire supply chain. Exactly. So the equipment used to collect data, the transmission of data, the storage, and each data source is sort of have its own firewall with logic. And then you have to ultimately protect the model itself, which is often not thought about, right? It's not the security privacy
Of course,
issues or
there's also the issue of you have to also restrict access to the model sometimes for fairness, etc. What I meant by is that if you're using facial recognition, for example, for police or law enforcement, you want to restrict access to the model so that someone cannot just try to stalk their ex-girlfriends, for example, right? So the access to the model needs to be protected, not also only for security, but also for privacy, etc. as well.
We'll take a quick break, Murat. So when we come back, we'll talk about your other paper, Explainable AI.
Sure. Thanks.
Thank you.
This is a Scientific Sense podcast providing unscripted conversations with leading academics and researchers on a variety of topics. If you'd like to sponsor this podcast, please reach out to info@scientificsense.com.
So we're back. Murat, we were talking about artificial intelligence, data security, data privacy, and really how to protect the whole supply chain of data collection, aggregation, staging, model building, and ultimately protecting the models themselves from attacks. You have another paper in a different area. Does explainable AI improve human decision-making? You say explainable AI provides insight into why for model predictions, offering potential for users to better understand and trust a model and to recognize and correct AI predictions that are incorrect. Prior research on human and explainable AI interactions has focused on measures such as interpretability, trust, and usability of the explanation. So this has always been a debate, right? So the debate has always been, can humans really use stuff coming out of a black box? Do they trust them? And if they do, does it really improve their decision making? So you have an experiment here. So what did you find in the experiment?
Yeah, exactly. So there is lots of work out there that we looked into where people find different ways to do explainable AI. One simple way is to, given a decision and a black box model, you may try to find rules that try to explain it. Yeah. And there are different ways of doing it. And there are others where they try to find out the importance of features, etc. So there are many different ways people try to come up with whether it explains the results or not. But they, at least based on what we found in literature, they didn't really look whether the explainable AI improves the overall outcomes and or whether it improves the individual's ability to detect errors. So in this paper, what we have done is with colleagues from social sciences and social psychology, we did a series of human subject experiments. Yeah. Where we look into 3 cases. In one case, of course, we look into 2 different scenarios, which I will explain in a second. In one case, the user has to make a decision just seeing the data. For example, we may give you an example credit card application, and you are asked to decide whether this person will be a bad credit in the future or not. Yeah. Or you could be, one famous example is Compass data. You would be given some information about people in the legal system, and you would try to predict whether that person will reoffend or not. In other words, you are just given a data about an individual, or you are given a data about a decision you need to make, and you will make a decision. So this is a base case. There is no AI, nothing. Just human is given some information. Yeah. The second thing is that now we give you the information, And we also give you what AI model says. For example, we present the users this screen where they see the instance of the data, and then they were given what the AI says the case. For example, we give you an example of credit card application,
Right.
like FICO score, age, job, etc. And then we say that, oh, AI model predicts this is a bad credit. So what's your decision?
Yeah.
In the third case, we give you the data, the AI model prediction, but also the explanation. So we are saying that, oh, AI says bad credit because the guy has defaulted 3 years ago, for example.
Right.
So now the question becomes, given which one of the trees would make much better decisions? We know the ground truth in the data at each point.
Right.
And we also look into two different scenarios. One is like just legal justice system. The other one is trying to predict someone's income, basically. And what we showed that giving any access to a good AI model, in other words, an AI model that is generally accurate, improve the people's decision making. In other words, they learn quickly that AI is good, and then they follow what AI says. But giving explanations didn't have a statistically significant improvement in correcting the errors or having more accurate results. So therefore, of course, this is one experiment, and we only look into 2 cases and some limitations there, obviously.
Yeah.
But what we are arguing is that there must be more research to understand how explainable AI would integrate it into the AI models. In other words, remember, and this also ties back to the previous paper, because in the previous work we were talking about attacks, right, and to the model. So theoretically, you want to bring human in the loop, and then you may ask a human to evaluate the results sometimes. In some cases, this is very simple, but in other cases, we would probably use explainable AI to do this kind of auditing. And GDPR, for example, allows a person to ask for a human audit when there is an AI-based decision. So now when you're doing this auditing, you will be looking at this explainable AI result, such as the rule I described. And you would be able to detect the errors and problems. And it turns out that that's not easy. So therefore, bringing human supervision combined with explainability wouldn't automatically solve the bias and fairness problems inherent in the AI models.
So if I understand this correctly, Murat, so in situations where human making a decision not just based on something coming out of the black box with no explanation, that compared to something coming out of an AI model with some explanation why, if you compare these 2 cases, you don't find much of a difference, right?
Correct.
And this holds for different cases that you have run. I have a hypothesis around this, Murat. Let me test this on you. So in the mid-90s, my group created a large machine learning model in a pharmaceutical company. And this was before Google was founded. And the model was really predicting the chance of pharmaceutical programs going forward, resourcing, and so on. And we can demonstrably show that the models are a lot better because we have historical data, both human decisions, as well as what the models would have predicted. But generally speaking, humans reject whatever is coming out of a model on the premise that they know better. And one of the reasons is that most decision makers, at least in business context, are getting paid on the idea that they are very good decision makers. Although we have no evidence humans are actually that good.
Actually, that's the reason we had this third component where we didn't give AI model prediction and just give the data.
Yeah.
And we can show that given AI improves compared to no AI. So if you think about three options, AI with explanation,
Right.
just AI, no AI. So we showed that anytime you have AI, it's much better than just human in our experiments. But there's no difference between AI and explanation versus just AI.
Yeah. So this one, when was this experiment done?
I mean, this is of course not in a business setting. This was done in like Amazon Turk
Yeah,
in
but
last year.
more recently, right?
Yes,
For
last
years.
year,
Yeah.
2020.
And I think the situation has improved substantially because people have gotten, more familiar with AI. They have, overall higher confidence. These mathematical techniques actually are useful.
And also we paid the people to be like more accurate, of
Yeah,
course, so they have incentive to be right. And once they figure out the AI is doing well, and remember, we by the way, in our experiments, we gave users feedback immediately.
right.
So they could see how well they are doing and they can adapt and so on. And they learn quickly to follow
Yeah,
the AI.
it's really interesting to me that, there's a raging debate on this. So it's really interesting that given the explanations of why why the result is a positive rather than a negative, it doesn't improve decision making. So does that imply that um, are they looking over the explanation, or they're basically just discounting the explanation? What is your hypothesis? Why
So I mean, we want to. That's something we want to follow up on. So it looks like, at least this is my hypothesis. We have to verify this. Is that people justify the results somehow? So because remember, AI seems to be doing well. You've seen some results, AI doing well and was right and so on.
right?
Now you think that the explanation makes sense, maybe, like because this AI was right and it's saying that it's doing it this way. So like in the explanation, it may come up with saying that, oh, I believe this will reoffend because he is younger and had one criminal history, for example, or something like a very violent criminal background. So then you may think, oh, that sounds reasonable. Yeah, probably that's the case. But then that may not be a very correct explanation. So in other words, maybe people are just justifying themselves that, oh, the AI model seems to be doing well. Why should I be suspicious about it? And the explanation may be making sense.
Did you get any data on if you look at the first two cases, that a plain human decision based on data and human decision based on black box prediction, what percent of the time do the decision makers changes her sort of ex ante decision, so to speak?
Yeah, I mean, like based on AI, you mean? So we
Based on
actually, in order to not to prime the people, you are randomly assigning one of these things. So we don't know. For example, if you were participating in our study, you would be in one of these worlds, but only one of these worlds.
Okay.
So we didn't look into. So you wouldn't be able to see a case where there is no AI, for example. You will be just seeing AI or AI with explanation. So we didn't know what would happen, like after AI or something.
Do you have a sense? How often people, since it's a binary decision in this case, how often do they switch their, sort of intuition based on the?
Basically, when we look at data and AI only, it looks like people go most of the time with the AI decision. There are only few people who did better than AI. In other words, like these people, let's say AI has 80% accuracy.
Yeah.
And then we run each of the cases at least 50 people and sometimes more. And only very few person, I don't remember the exact numbers now, could beat the AI. And of course, whether it's statistically significant, I don't recall whether we looked into it. But it was hard for most of the people to beat AI. So therefore, it was easier for them to go with the AI model, and they didn't change their decisions too often. And when they changed it, actually, there are many people who didn't improve at all.
Yeah. I know that you didn't do this, but do you have a sense of if you take a more complex problem, rather than a dozen features, now you have, let's say, 100, a very complex problem, let's say. Do you have a sense of how people will behave in that context?
What I'm saying is our sense is that this is very complex, and given the and as the complexity increase, the explanations themselves may not be good enough to find issues with the model, and we may need to have more rigorous auditing, and this also ties back to security. In other words, looking to AI model, for example, how well it's doing on certain subclasses. Remember the bias we mentioned about, and there is already lots of work on measuring biases in the model. For example, does it more likely to predict reoffend for African Americans, for example? So you have to couple explainability with this kind of online or real time or as close as possible auditing of the results for quality purposes, like how well the model is doing, how often it's wrong, but not overall, but in certain subgroups, in which cases, so that you can diagnose issues earlier on. Of course, explainability may help if you use in combination with these. We haven't tested that, but I have that hypothesis. So I'm not saying that explainability is not useful at all. It may have usage, and it will probably, but you need to combine it with other ways of diagnostic problems. And that is especially needed, I think, in more complex problems and settings. Of course, it's very hard to test it on Amazon Turk for very complex. That's the reason we look into even simpler ones.
Right. Yeah, so Murat, in conclusion, you're doing a lot of work in this area of security and privacy. AI is gaining traction, it looks like. A lot of industries, a lot of companies are getting into it. From a security and privacy perspective, what do you think is going to happen in the next 5 years, both from a technology perspective as well as from a sort of a regulatory compliance perspective?
I think both regulatory and compliance will be going more and more because the companies controlling this data and so on would be critical. And I think we will be seeing more of an issue with respect to the security of the models as well, and that will be also regulated. And from technology perspective, I think people will be understanding more of the issues with AI models. So currently AI looks like we'll be solving everything and we will be controlled by robots anytime, but I don't think it will be happening anytime soon. And I think we will see some problems like the ones we mentioned, and that will hinder some of the, I think, progress. But overall, I think we need to worry more about the AI and security and privacy interactions, and have the right regulations and technology work together, basically.
Right. Excellent. Yeah, this has been great, Murat. Thanks so much for spending time with me.
Thank you so much for having me on your podcast. So thanks.
Thank you. Good luck with this research.
Thank you. Bye.
This is a Scientific Sense podcast providing unscripted conversations with leading academics and researchers on a variety of topics. If you'd like to sponsor this podcast, please reach out to info@scientificsense.com.